Good morning, Algebra 2 Concept students. So today I'm just going to go through kind of an example of each of the different counting principles that we've discussed so far, and then give you some more time to work and complete those assignments and get those submitted online. The first one is our inclusion-exclusion principle, which is used to solve a problem similar to this, where it says of the 540 seniors at Central High School, 335 take math, 287 take science, and 220 take both. How many take neither? So if you remember our formula, the inclusion-exclusion, in this case, would be the number in math union science, which is the same as math or science, is going to equal the number in math plus the number in science minus the number in the intersection of those, which is the same as and. So in this case, we have 540 seniors, 335 of them take math, 287 take science, and 220 take both of those. And so therefore, if we do the math here, do the addition, add those together, then subtract 220, I believe we get the union to be 402. So 402 of those 540 seniors would take either a math or a science class, which also means or both. So how many take neither? We'd have to take 540 and subtract the 402. So there'd be 138 that would take neither. You can also work out this problem by using what's called a Venn diagram and using a couple intersecting sets that we're going to call math and science. And then we know that there are 220 students that take both of them. So there's 220 in the intersection or the overlapping part of that circle. There's 335 that take math. So 335 minus those 220 would give us 115 that take math only. And then the 287 minus the 220 would give us 67 that take science only. Now, there's 540 seniors total. So in this outside section, there would be another 138 that take neither one of those. If we add these up, those four numbers would add up to be the 540. The next principle we talked about is the multiplication counting principle. And we'll do a couple examples like this. One of the types of problems is in how many ways can 8 people line up in a cafeteria line? So again, if I have 8 people lining up, I would make 8 spaces here. And then how many choices do we have for the first person in line? We'd have 8 choices. And then 7 for the second person, then 6. And all the way down to 1. And we would multiply these together because it's the and. When you're multiplying 8 numbers all the way down to 1, that's the same as 8 factorial, exclamation point, which you can find on your calculator under math and probability. And that would come out to be 40,320 different ways. Another example, the counting principle, and how many, if 10 runners run a race, and how many different ways can prizes be awarded to first, second, third, and third. So we got to give away that first place medal or trophy. There'd be 10 different people that could win that. Once that's placed, now there's only 9 that can win second, and then there's 8 that can win third. And once again, we would multiply these together. So there'd be 720 different ways of awarding those prizes. We then talked about combinations and permutations. Important that you realize that if we're talking about a permutation, that order is important. Order is important in a permutation. In a combination, order is not important. So when I ask the question, how many ways can a club with 10 members choose a president, vice president, and a treasurer? So the order here is important because these offices are different. Therefore, it's a permutation, and it's 10 people, and we're choosing 3 of them, and order matters. We can find this again